Hello, my name is Michael Wilson. I'm a postdoc researcher at Lawrence Berkeley Lab, and I'd first like to thank the organizers for giving me the opportunity to talk about DESI High, Skill of the Dark Universe. DESI High is essentially a chemistry set for 21st century cosmology that provides hot-off-the-telescope DESI data using Jupyter notebooks hosted by Binder and available on GitHub. It provides essentially everything that's needed for a student to get up and running their own experiments based around DESI science. I'm fortunate to have some of the world's best cosmologists collaborating with me on the DESI experiment, and they're going to take roughly a minute to introduce you to the DESI experiment.
DESI is the greatest cosmic cartography experiment we've ever done. So we're trying to map out where all the galaxies are in the universe out back in time for the last 12 billion years of its history. As an experimental physicist, you do these experiments, you push the boundaries, but DESI is taking it a huge leap forward beyond the current surveys and what we have at the moment. But it's just really exciting the potential for not only understanding dark energy, but having serendipitous discoveries as well.
Dark energy is one of the most interesting puzzles that we have in all of science. Our understanding is that the universe's expansion rate is actually speeding up with time, and we don't have yet a very compelling physical explanation of why that should be. DESI is part of an international effort that is trying to understand this really big question.
My 8-year-old kid is asking me what the universe looks like, what's going to happen to our universe. So this is the question human being has been asking since ancient time. So it's like dark energy is a big piece in a jigsaw puzzle of the universe, 70 percentile piece. And if we know what this is, we will be able to see the true picture of the universe. And so in this sense, I think our mission is very important.
So I'm entirely in agreement that our mission is very important, and I'd like to introduce DESI High. So this is our GitHub repository where we make this idea come to fruition by providing the hot-off-the-telescope DESI data and the Jupyter notebooks necessary to use it. So I'm fortunate to have expert scientists in DESI available to me that have contributed to help me make this available, together with students at Lowell High School in San Francisco who have been actively using and helping me develop this resource. As you will see in a minute, everything is hosted on Binder, so it's free and accessible to anyone with an internet connection, while we use Travis to ensure a successful deployment every time. As of this month, DESI High is available in Spanish, which is very exciting for us. And I'll introduce you to the other features and events that we intend to either build or implement in the next few months, and describe the programs that we hope to set up for providing access to underprivileged groups. In particular, we have an elite team of scientists across the globe that are ready to get things started for any high school teacher that might be interested in getting this initiative going. So without further ado, let's look at our first notebook. The first notebook explores the beginnings of cosmology with Edwin Hubble in 1929, observing distant galaxies, including Triangulum, the Large Magellanic Cloud, and 23 others. What he noticed was that the colors of light emitted by hydrogen in the distant galaxies were shifted relative to those in the laboratory. From this, he was able to deduce Hubble's law, that the universe is expanding with distant galaxies preferentially receding from us. The second half of the notebook explores Saul Perlmutter, a Nobel Prize-winning cosmologist at Lawrence Berkeley Lab, who in 2011 won the Nobel Prize for the discovery of dark energy, the mechanism by which the expansion rate of the universe first began to accelerate. In this first notebook, we provide the data necessary to recreate these historic moments in cosmology and finish with an introduction to Saul's receiving the Nobel in Sweden, Stockholm. Within the next few weeks, we hope to appoint honorary principal Perlmutter at DESI High. Our second notebook investigates the design of the DESI instrument. In order to reach up to 30 million galaxies in the next 5 years, DESI will target those that are actively forming stars. This is challenging as an ill-designed instrument can provide erroneous distances for this particular class of galaxies. By the end of the notebooks, students will have tackled the dispersive spectrograph, the mirror of the telescope, the detector used to absorb light, the effect of the atmosphere and the moon, and essentially designed a DESI instrument. This motivates the first science report for students at DSI High and introduces them to Tanvir, a Harvard graduate student who has most recently worked on this problem, and Satya, one of DESI's leading observers. Our final example is the first with real DESI data. It explores the end state of our own sun, which may explode as a spectacular planetary nebula and form a white dwarf, an ashen carbon-oxygen relic supported solely by spooky effects of quantum mechanics. The DESI white dwarf we provide lies just above Ursa Major, or the Great Bear in the Sky, while we include complementary data from the Gaia and other satellite missions. In this notebook, we use a library of models to measure the temperature of the white dwarf and the acceleration due to gravity at its surface. In total, 6 notebooks are available currently, with a couple more in the pipeline, and we will build up the curriculum by making approximately 1 notebook available on a monthly basis. With that brief introduction, I'd like to summarize our initial tests in the field at the fantastic Lowell High School. Based in the Bay Area, Python is rife, unsurprisingly. What is surprising is the fact that only 30% of the students had been introduced to Jupyter Notebooks, a fact that we soon put right. The DSI High events that we organized spun off many discussion groups at Lowell High, both for science and data science, and the students were certainly keen. But at the end of the day, we asked a fundamental question: would they return to DSI High? After a resounding yes, we asked them why. The students were sharp enough to appreciate this unique opportunity that certainly my own and previous generations would have loved. In conjunction, we asked the teachers at Lowell High what they thought. And I quote, "The opportunity DSI High provides all science students to work with real-world data alongside scientists in the field is a dream come true for me. DSI High is a unique chance for all students to access a world of academic research and collaborative science at work. I'm thrilled that our students have a chance to put their learning to the test while also being given scaffolds to increase their skills in science and coding. The level of interest and engagement DSI has generated has been wonderful to see." With the restrictions on movement and the influx of remote connections to students, there's perhaps never been the same opportunity to implement a program such as this. To fully exploit it, we intend to provide the students with the competitive skills they will need for their future as either a scientist or a data scientist, or a scientist, or a data scientist. While, like any good Disney movie, there should also be something for all ages. September was a particularly exciting month for DSI High, with a full release of the available material in Spanish, coinciding with the start of National Hispanic Heritage Month. At the end of October, we have events running in both English and Spanish at the Bay Area Science Festival, and are also running an event at a science festival in Mexico. To commemorate this special occasion, we've launched a challenge to create a unique notebook. To get students and others started, we've provided the details necessary to recreate observations of Venus historically performed by the Mayan civilization. After this successful Spanish release, our next program will be to set up Bengali, ably supported by DSI graduate students. With that, the world really is our oyster. With DESI scientists spanning the globe, in particular in Europe and the United States. Finally, we'd be remiss to only target the students that are fortunate enough to have a laptop or iPad simply hanging around. We intend to set up programs that provide loaner laptops for the Bay Area based on end-of-service stocks that are available at national labs, and a paper binder program that posts a binder of all available material to students recommended to us, together with an astronomy book that's familiar from all graduate school applications that contain the question, how did you first get interested in astronomy? With that, I would like to thank you for your time and provide a reminder that any time, expertise, and financial donations are more than welcome, with my contact details provided at the bottom. Thank you again.